and delivery nozzles, which are welded to the casing. The supports which fix the casing to the compressor skid, casing sizes, and the number of impellers are indicated in the compressor designations by the digits following the compressor model. For example, 2BCL807 is the designation for a two-stage back-to-back compressor, size 800 with 7 impellers. Vertically split casings are used for relatively high working pressures and/or specific gases. The shape and thickness of the casings depend on the pressure ratings. This is a horizontally split diaphragm bundle. The slot for the seal O-ring. The O-ring is fitted before closing the lower half of the diaphragm bundle.
Piano, piano.
Suction, intermediate, and discharge diagrams create the gas flow path within the stationary components. The suction diaphragm conveys the gas into the eye of the first impeller. The annular suction chamber of the diaphragm bundle, where a fin is made to direct the flow of gas from the suction volute to the eye of the first impeller. Intermediate diaphragms perform the dual function of forming the diffuser passage and the return passage to channel gas to the eye of the next impeller. The discharge diaphragm forms the diffuser for the last impeller as well as the discharge volute. The diaphragms are usually horizontally split and are made of cast iron, forged steel, or stainless steel. You can see the special aerodynamic design conveying the suction gas to the eye of the impeller without forming a vortex. The bolts which lock the diffusers in position in the diaphragm bundle so that they do not fall out when the upper half is turned over to be coupled with the lower half. The labyrinth seals, installed between the diaphragm bundle diffusers and the rotor impellers. These also are split in half. The centerline lock screws for the diaphragm bundle labyrinth seals. They ensure that the seals are not dislodged. Easily removable labyrinth seals are installed on the diaphragms at the impeller shrouds to prevent return flow from discharge to suction, and on the shaft sleeves to eliminate interstage leakage. This is the compressor rotor. It is composed of closed-type impellers, shrink-fitted and keyed to the shaft. The balancing drum, required to balance the thrust that is created on the rotor during compressor operation. The spacer rings that are fitted between the impellers. Locking rings for the rotor. They tighten the impellers, spacers, and balancing drum into a single assembly. These are the seats on the rotating element of the compressor gas seals. This is a typical gearbox to centrifugal compressor drive coupling. The hubs of the coupling are force-fitted on the shafts, which are to be coupled, and coupled to the spacer. The spacer transmits motion from one shaft to another. The centrifugal compressor has 2 journal bearings and 1 thrust bearing. Tilting pad journal bearings are generally used. This is the journal bearing number 2, i.e., the one on the non-drive end. This is the journal bearing number 1, i.e., the one on the drive end. This is the compressor thrust bearing. Here it is shown in its housing. These are the tilting pads of the bearing. Some of these hold on the thermocouple heads. The filament is lodged in a slot made in the body of the bearing. Double-acting tilting pad thrust bearings are installed. The bearing pads can be fitted with thermocouple elements for temperature detection and with load cells in high-pressure applications to measure actual axial thrust load. Shaft end seals eliminate or minimize compressed gas leakage from the compressor casing, as well as ingestion of air into the casing. The type of seals depends on a compressor's service. The compressor rotor is then lowered into the lower half of the diaphragm bundle. The radial position of the rotor, in relation to the diaphragms, is the same as the rotor would have resting on the journal bearing pads once the compressor is completely assembled. Now the procedure for closing the diaphragm bundle begins. Great care is necessary when closing the diaphragm bundle to avoid damaging any components. Before proceeding with tightening the centerline bolts, it must be checked